Hey folks, here's another screencast, another optimization example I'm calling crop yield. Here's the statement of the problem. A mathematical model used for the yield, which will denote y, of an agricultural crop as a function of the nitrogen level in the soil measured in the appropriate units is given by y equals k times n all over 1 plus n squared, where k is a positive constant. What nitrogen level gives the best yield? This is an optimization problem. You can see the superlative right here, best. That's the fingerprint of the fact that you're optimizing. Let's use calc to find the optimal value of the nitrogen to give the greatest yield. So we're going to look for the maxima of this function. We know that maxima occur at critical points, so let's find the critical points. Critical points come in three flavors: endpoints, stationary points, and singular points. Endpoints are endpoints of our interval, in our case our domain maybe. So our independent variable here is n, so we should ask the question, what's the smallest n can be and what's the biggest n can be? Well, the smallest n could be would be 0. You can't have a negative level of nitrogen, so the smallest n could be is no nitrogen, 0 nitrogen. And what's the largest n could be? Well, n could be as large as you want, so we're going to put infinity. So this tells us that there's one endpoint, n equals 0. Singular points? Well, singular points happen when the derivative doesn't exist. Here we're looking at our function. We can see that it's a rational function in n, and we never really get division by 0 because n squared is always positive and 1 plus a positive number is always positive. So there's no natural singular points that come from the domain. But there might be a singular point that's introduced by taking the derivative. So let's look at stationary points and singular points at the same time. Let's look at y prime. So to calculate y prime, we need to use the quotient rule. So that's the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now you can look at the derivative and you can see we're never really getting division by 0 in the derivative because 1 plus n squared is never 0. So there are no singular points for this function. We'll just proceed to look for stationary points. So stationary points are where the derivative equals 0. So let's just write 0 equals what we got for the derivative, and I'm going to multiply through here. See if that gets me anything. And I can multiply through by the denominator, multiply both sides by the denominator. So that gives me k minus kn squared. Simplifying my numerator. And I can factor a k out. I get that. K is positive, so I can divide both sides by k and not change anything. I get 1 minus n squared, and that factors into 1 minus n and 1 plus n. So the solutions to this equation are n equals plus or minus 1. But going back to the thought, or our conversation, or thoughts on the endpoints, we agreed that the level of nitrogen can't be negative. So let's get rid of one of those. It's n equals just 1. Let's make our number line then. So we have an endpoint at 0, and we have a stationary point at 1. Let's look at the derivative. Well, the formula for our derivative here is on the right-hand side of this equation, and the numerator is simplified to this. Our denominator is always positive, so the only thing that affects the sign is 1 minus n squared, and we factored that here. So let's put those factors on the vertical, and then we'll put y prime of n here. Well, looking at the second factor, you can see that's always positive, because n on our interval is always positive, so 1 plus a positive number is always a positive number. It's the other factor that changes sign. It starts positive, and then it becomes negative. So our derivative, y prime, starts positive and ends negative. And by the first derivative test, n equals 1 is a local maxima. So let's go to the next page. This shows yield is maximized when n equals 1. And that's what we wanted to show. That's it. Thanks.